Hi, welcome to my presentation about Servala, the Open Cloud Native Service Hub. In these next 30 minutes or so, I want to introduce you to the technical perspective of Servala. But before I start with the technical part, who of you knows what Servala is? A few already, that's good, not the others. So we call it the Open Cloud Native Service Hub. But in other words, it's a multi-cloud app store for managed Kubernetes native applications. That's what I came up this week when I thought about how could I better explain what it actually is, not using so many marketing words, but I would say that's exactly what it does in the background. So yeah, it's an app store, as already said. That's how it looks like on the website today. So you can browse to servala.com and have a look what's already there. A lot of services are listed, a lot of services are already available, a lot of services are coming soon. So express your interest if you see any service there which you are interested to have as a managed service on any cloud, on your cloud or wherever. I want to really put the emphasis on the multi-cloud part here. So that's why when I go to a service detail page, I can see which clouds are there to run this service when you want it. So the idea is that if you see a managed service, a service which you're interested in, you can also choose on what cloud provider your service is running on, even on your private cloud if you're interested. So that's just an example how it could look like. But that's all about the marketing part, what the product is. I want to talk about the technical part of Servala today. And this is the technical architecture, how it looks like as of now. So everything starts at the Servala web portal. So the end user using this product is connecting to a web portal, which you will be seeing later how this looks like. This web portal is connected to an IDP, an identity provider, which provides login and registration facilities. It is connected to an ERP system, which knows all about the customer data and the billing information. But the most important part of the portal is that it is connected to several cloud providers. Each of these cloud providers, that can be CloudScale, Exoscale, Swisscom, Switch, Green, Ionos, whatever, is out there and working together with us. They can have one or multiple zones. Usually this is a data center. Exoscale, for example, has around 8 zones. These are in Germany, Austria, Switzerland, and so on. And each of these cloud provider zones, we have a control plane running. The control plane will be introduced later, but this is important to understand that each of these cloud provider zone has its own control plane running. So they are really on their own. So they don't have to be connected to the other stuff. They are on their own. So if another zone has a problem, it won't affect all the other zones. And then the control plane controls one or multiple service clusters, and the service clusters are the clusters where the actual services are running on. But let's begin with the user-facing part, the portal. This is currently being worked on, and it really puts the emphasis on self-service first. So the reason for that is that we are very keen on giving the end user the possibility to do everything themselves. We do not want to work on tickets. We want to empower the user to do all the things themselves. I mean, it's a standard SaaS approach if you wish. So the first things first, the user has to be able to register for an account and to log into the system. Then we put a whole lot of effort into making this system multi-tenant aware. And this is done with organizations. We will see later what that actually means. But the portal is in the center of the organization management. It provides you the service catalog. So on one hand, we have the website, which lists all the services available, but the portal has its own service catalog, which lists the actual available services. The portal allows you to create a new service instance, update the parameters, change stuff there. You can see what instances you have available, and you can also delete an instance if you don't want it anymore. We have a lot planned. these things here is meant for the MVP, which we are currently developing. When this is done, we will continue with other features like support, billing, billing things, and metrics and whatnot. But this is the main features that we are currently working on. The portal is a classic Python Django web application with the Postgres database. So we have chosen the boring route here to be able to move forward fast. When we started this project, we had the idea of building something more Kubernetes native, but then again, we figured out that is way too much work. So we figured out we do something standard web development style, and this has proven to be a good idea because we were able to move forward quite fast with this project. It's basically a backend API aggregator, so the portal connects to various different upstream systems to get information, to write information, to update information. It is the center of the multi-tenancy with organizations, so everything is connected to an organization, so each and every service instance has to be part of an organization. Users can be member of one or multiple organizations, and they can even have different roles in different organizations. So potentially in one organization they have list-only rights, and in the other organization they can also create or delete instances. It is a classic web UI. Also here we have chosen the boring standard part of using HTML, CSS, and to bring some dynamic into it, we have chosen to use HTMX. If you've heard of it, that's cool. It's a very easy way to bring some fancy dynamics into it. The API is planned. We have not forgotten about the API. The web UI is first, but then again, we also want to empower GitOps. And for GitOps, you need an API to talk to. So that means the API will be coming quite soon after the web UI is finished. When we have such a web application which aggregates multiple systems, we have to be very well aware of the source of truth of our data. So having multiple places to store the same data is not a good idea, so we had put a lot of thoughts into where is the source of truth of our data. For the registration and authentication, so the user base itself, we have chosen Keycloak to be our source of truth. So all user accounts, they are living in our Keycloak instance, and the portal is using OpenID Connect to authenticate a user. The customer data is stored in Odoo. That's the system we have chosen for ERP, billing, and accounting. That's also why the billing and invoicing happens through Odoo. And the portal actually connects to Odoo, gets data, writes data, and displays that to the customer. The service instances themselves, they are stored in the control planes. So the control planes are on their own. The portal just writes information to the control plane and then can go away, and everything continues to run. And this is also very important for resilience of the whole system. We don't want to have service interruption because the portal is probably not available for whatever reasons. So the control planes are the master of the service instance information. And the service offering, that's the thing which is stored in the portal. So there we define which service is available where, and what parameters we expose, and all these things, this is stored in the portal database. So now let's have a quick look what it means to get a service instance. So the first thing first, you will be seeing a service offering which is defined in the portal database. And then when you have chosen a service, for example PostgreSQL, then you can choose the cloud provider where you want your instance to be running on. The next thing, you can choose a zone if there are multiple zones available. And last but not least, you enter your parameters for your instance and then click on the Save button. An interesting fact is that each of these zones can have different service parameters exposed. Because zones can have different features available, some of these zones might be able to expose a service as a TCP endpoint, some of them probably not because of infrastructure reasons. So these service parameters, they are dynamic per control plane. And to make that happen, the portal connects to the Kubernetes API endpoint of this control plane and retrieves the available parameters via the OpenAPI specification, which is neatly provided by the Kubernetes API server. And with that information, the portal is able to create a dynamic form, which is really what is possible on the backend. So this is neat. We don't have to create all the specifications on different sides on the backend and in the front end. It's the developer just defines it in the backend, and then it's automatically available in the front end. This is also great if we upgrade a service, add new parameters, remove parameters. It's reflected in the portal automatically. Instances themselves are also tracked in the database. The database knows which instance is running, but that's all. The database does not contain any configuration parameters. It's just there to list the instances available. Deletion is a bit a special case. You don't want to delete your production database with a single click and then be sorry. So, of course, it asks you, are you sure you want to delete this instance, and asks you again about the name. But in the back end, we also have deletion protection in place. So the control plane cannot easily just remove an instance. The deletion protection has to be removed first before a instance can be deleted. And this is done by the portal if you do it on the GUI. So the GUI asks you, are you sure you want to delete this instance? And then in the control plane, removes deletion protection and deletes the instance actually. So we are very careful of not being able to delete instances out of bad luck. This also helps us to make sure if there is a bug in the control plane doing nasty things, trying to delete instances, it's not possible without removing deletion protection first. We are still working on this portal. We are in the MVP development phase, so this is currently ongoing as we speak. More features will be added after the MVP launch, so we hopefully are ready by summer to launch the MVP. We developed this thing on our own product, which is called Kodi, based on Fortcho. The idea here is to eat our own dog food. We do believe that the things we are building, they are working, and so to be sure, we are using our own services as well. And this QR code actually brings you to this Kodi instance where the source code is living. Because we open source the code already, it's HEPL v3, so if you're interested, you can see what we are doing live. And speaking about live, I have prepared a little demo. Let's see if it works, because we are directly connecting to the development environment right now. The last time I tried that, it didn't work, so let's see if the demo gods are with us today. Click on it. Yes, it works. So I'm already logged into the Servala development web portal instance, and I'm greeted with my name. You see here an organization switcher. If you log in the first time, it's empty. There is no organization displayed, but I already have one created here, the Acme Corporation. I click on that one. You are greeted with an empty page because we are working on that, but you can have a look at the service offering already. So there are services available here in this demo test development instance. And for the demo, I am pretty sure that Fortcho will work. At least I tried it several times. I can choose which cloud provider I want to have this Fortcho instance running. I choose Exascale because I hope this one will work. Then we have the service provider zones. Here we only have Geneva as in the drop-down. I give it a name. Let's call this one Meetup. Because this thing is currently being developed, the form is not really user-friendly yet, but it works. We will be putting a lot of effort into making this form a bit more user-friendly. But I have to, for example, write under which domain I want this Fortcho instance to be available. That's service-specific. Then I also have to write an information where to store the connection credential. This will also be much better when it's finished. But now I have entered everything. I click on the Save button. In the backend, the portal has now connected to the control plane on Exascale Geneva, created this instance for me, and now it's being provisioned. And usually this takes about a few minutes. Let's see if it's already available. Not yet. I can show you another instance which is running. For example, this one here. You see it is available, ready, and here is the URL I can connect to this instance. And yeah, so this is the Fortune instance which was provisioned before. Let's quickly see if the other instance is already up and running. Yes, ready through, so that one worked. Let's see if the URL is also working as expected. Yes, and that's the Fortune instance which is really provisioned right now. I can also update the configuration. When I click on the edit button, it retrieves the current configuration. It gives me a form which I can change, where I can change configuration parameters. And now it's time to say goodbye to this instance. So I click on the delete button. It asks me again about the name of the instance. I click on confirm and delete instance, and now it removes deletion protection and then deletes this instance, and it's gone. So that's where we are today. We are finalizing a few things here and there before we can make it public. Good. Now you have seen the front end. I want to show you a bit more about the back end, what's going on the control plane side. The control plane where all the things are happening. This is a high-level view of the control plane architecture. So we have the control plane here, which is actually a Kubernetes API server, and we have one or multiple service clusters, which is managed by the control plane. So there are two things, the control plane cluster and the service clusters. This control plane is based on Crossplane. It makes heavy use of the provider Kubernetes and provider Helm. If any one of you know the Crossplane, probably already heard of it, using it. Okay, so the provider Kubernetes and provider Helm is there so that we can connect to multiple clusters from a central control plane. As said, the control plane controls the service instances which are actually running on the service clusters. We can support as many service clusters as we need because Crossplane is quite flexible on that with the so-called provider configs. We do store Crossplane claims in namespaces. Each organization gets a namespace on this control plane. So this is how we implement the multi-tenancy on the control plane side. And we are very much looking forward to Crossplane version 2, which should be out in August, I've heard, or read today in the GitHub pull request, because they are refactoring some ideas they had before, and we can say goodbye to claims. For those of you who know Crossplane, this is the thing which makes it so complicated, and we also don't need it, so we are very much looking forward to this version 2. It will be a bit of work to refactor our stuff, but I think it's worth it. The service clusters, yeah, I must say this is a bit boring part of our presentation right now, because it's just any Kubernetes cluster. It's really nothing special. It can be any Kubernetes. In our case, it's OpenShift, but it could also be Google Cloud's Kubernetes or whatever. So it doesn't really matter, because it's just like there is workload running. So we do have some service-specific operators running on these service clusters. For Postgres, we are using Stackgres. But for others, we are just using Helm charts. So there we don't need an operator. So it really depends on the service itself, what we need on the service cluster. We have some admission webhooks running on these service clusters. They are communicating with the control plane. They are, for example, used for the deletion protection. And they are also used to validate configuration. So speaking about these managed services running on these clusters, we do have a thing which we call the Servala framework. This thing helps us to make it a real managed service. This framework is completely based on Crossplane, so it makes heavy use of all the things Crossplane offers us. And we have the vision that we have an input, for example, a Helm chart. We move it through this framework, and afterwards it is a managed service. So the framework adds all the magic so that a service gets managed afterwards. You might ask what we understand on a managed service, because maybe you have different ideas what a managed service is. We think, from a technical perspective, a managed service automatically, without any user intervention, gets regular maintenance, it gets security updates automatically. Oh, as a user, don't have to care about these things. It gets version upgrades, or at least it offers major versions upgrades to the end user, so that the end user can say, I want to move from Postgres 15 to 16 and just change the version, and then the framework does its job to make this upgrade happen. Yes, data backup and restore is handled, also monitored and verified, and made sure that the restore works when it is needed. Monitoring and alert handling is automatically added to the service and taken care of. And metrics are collected and logs are collected as well. From the business perspective, a managed service adds an SLA, so it says that it's up for so and so many % of time. And also 24/7 support is an addition which is important to a managed service. So this is all. I think that I would say this one is the framework part, and this is the business part, which is available for all services through Servala. A quick introduction to Crossplane, because this is the center of the heart of the Servala framework. So we have this threaded claim. This is a thing which is defined by the platform team. In our case, this is defined by Servala. It exposes the parameters to the end user, or in our case, to the portal, where the user specifies what they want from the platform. And then the platform makes sure through this composite resource definition and the composite resource and the composition and the managed resources, all these magic things of Crossplane, so that your service in the end is a reality and not a dream anymore. This is how such a Crossplane claim looks like. So you have seen the example of Forcho, and in the background, what we have not seen, because the portal was between us and the control plane, this is the Vision Forcho object, which was created by the portal. Here we specify a name, an email of the admin of this Forcho instance, maybe a version and other stuff. But this is the custom API, which is defined by the framework. And because we are using Crossplane and the Crossplane composite resource definition, how this thing is called, we have a consistent API structure. So all of our managed services provided through this framework have the same feeling. So when you would see the same example for Postgres, it would look very similar to that. So that this is the great thing about how we are doing it in this framework. I briefly mentioned these composite resource definitions. Crossplane abbreviates that with XRD. So this is the schema for the API definition. It's very hard to read, but it's the thing which defines the API to the end user. So it's very important that we define it correctly here. It is consumed by the portal to provide this formula for the end user. And this contains the names and all the parameters and the defaults and the description and help text. So in reality, this file is huge. So this is the whole API definition. When this claim is applied to a cluster and everything is correct, the composition comes into play. A composition in Crossplane is like a template for Kubernetes objects. So there is a lot of magic behind this thing. We are using composition functions, which is also a special thing in Crossplane. We call this function appcat, which is a Go code Go-coded computer program, which takes some input data, and with this input, it generates all the Kubernetes objects required. And this is actually where the managed service happens. So in this function appcat, the whole business logic is encoded. It adds backup, especially for this service, because the function knows how to add backup for this service. It adds alerts, it adds metric collection, it adds everything which I've shown you before to make this a managed service. So this is really all happening here. This is the magic. Composition function is an intelligent generation of Kubernetes resources. As mentioned, it adds all these day 2 operations facilities to a service running on Kubernetes. We write these things in Go, but you could also write composition functions in Python, even in Bash if you wish. It just gets input, does something, and provides an output, and this has to be compatible with the API of these composition functions. It's also available on GitHub, so we do open source everything we do, not just the portal, but also the control plane and the framework, and everything is available there. So this is where all this day 2 operation magic happens. That's not everything to the framework. There is more. We have a custom API server running on the control plane, which, for example, provides us a list of available backup snapshots. So if a user wants to restore a backup, the user has to know what backup snapshots are available. And this custom API server connects to the backup repository and provides a list of available backup snapshots. We do have these admission webhooks. They are an integral part of the framework. They provide value. They check the values for feasibility, so that you cannot, for example, downgrade a Postgres instance, because we do not support that. This is an example which is handled by the admission webhook, but also this deletion protection, which is really a very important part of the system, is done by these admission webhooks. We have some custom controllers running. As you might know, a stateful set resizing is not so easy. So if a stateful set needs a bigger disk, you have to delete the stateful set and recreate the stateful set. And this is a very manual and error-prone task. This is automated in a custom controller of ours. And we have some others. That's not all. There is even more. So to make a managed service, we need KTAB for backups and restore. We need Prometheus to collect all the metrics. We use Loki to collect the logs. We have Grafana for the visualization of logs and metrics. We have the alert manager, which alerts on metrics. We have Renovate for staying up to date all the time. We have projects in to provide configuration management for all these many clusters we have. We have OpenShift for Kubernetes, we use Cilium for networking, and probably I forgot a lot of things. But you see, to make a managed service possible, you need a lot of tools, which you have to make sure they are running and configured correctly. Yeah, we are coming to an end of my technical journey through Servala. Let's briefly look back what I have told you in the last few minutes. We have the Servala web portal, which is a Django web application, classic web UI with HTML, CSS, HTMX. We have Keycloak for our IDP. We have Odoo as the European CRM system. We have a lot of control planes. Each cloud provider zone has its own control plane. And we have multiple service clusters per service provider zone. Listed here again, the portal, the control plane, the service cluster, and also the framework. Without the framework, it would not be possible to provide these managed services. Yeah, with that, I'm open for any questions you might have. Yes?
When you talk about the managed services with the SLA and stuff, I'm not sure if I got that correctly. Is that for all the services that you are basically selling through Servala? And is it for everything?
So the question is if the SLA and support is for all services listed on Servala. And the answer is yes, because that's the unique selling point of Servala. All services you get through Servala are managed.
And this
For now, it's managed by ๊vɪʒn. But in the future, we are open to onboard other managed services provider. But the idea really is that if you get a service through Servala, it's managed. Any other questions?
You have shown the password. How is the password management made in Servala? So like hundreds of databases, it's per service, or is over portal a big secret management?
So the question is about password management, how this is done for a service instance, if I understand that correctly.
Yes.
Yeah, so if each service creates its own credential and provides these credentials to you. So for example, if you provision a Postgres database, it generates their own credentials in the background, and then you use these credentials. But this is all stored on the control plane. The portal only displays it to you, but has no knowledge about this database, about these passwords in general.
One more question about the billing. We come from Q-Cost. So I'm wondering how it is built. If you have so many service providers there, there's one big bill that comes from ๊vɪʒn, or is it built by provider? Or do I need to configure them by adding some credentials or stuff?
So the question is about how does billing work in Servala. So today you will be getting an invoice by ๊vɪʒn, from ๊vɪʒn. So when you order a service through servala.com and you choose, for example, Exascale, you will get an invoice from ๊vɪʒn. But this can change in the future. So there are plans that you, for example, get a Servala service through Exascale. So you are an Exascale customer, you go to Exascale and you order a Postgres database from Servala through Exascale, then you get the invoice from Exascale. Yeah. And the billing model is currently being finalized. So all services you get through Servala do include the cloud services, the cloud compute infrastructure and the managed service, and potentially some enterprise subscriptions, licenses, whatever is needed, and you get one price. Yeah.
So how would I get the parameters to consume, for example, the Postgres? Does it get delivered in the portal, and then I have to copy paste some values YAML chart somewhere else? That seems rather complicated.
Yeah.
Or is there a way to, for example, in the same cluster to get injected the Postgres cluster?
Okay. So the question is, how do I get the connection credentials into my application? So for the MVP of Servala, you will have to copy paste it. But this is not ideal, we know that. So that's why the API which we are planning is very important. So the end goal is that you have your application deployment configuration, be that in GitOps or in your CI/CD pipeline. And the API is not specified yet, but you somehow will get these credentials. Then you will poke the API of Servala stating I want a Postgres database, and the result are credentials in your application then. We have another product which Servala is based on. This is called AppCat, the application catalog. You might have seen that before in these API definitions. I must say that we are working on this application catalog since many years. It's not something really new in that sense. The new thing is that we have this Servala web frontend and the control plane a bit more distributed and so on, but the managed services we are doing since many years. And today, if you have an Apuyo account, which is another product of ๊vɪʒn, or a managed OpenShift cluster, which is another product of ๊vɪʒn, you will get direct access to the control plane. And then you can specify this object you have seen before, this ๊vɪʒn fortune, directly in your GitOps pipeline or in your CI/CD pipeline, and apply this to the cluster. The result is a secret in the same namespace your application is. And then in your deployment, you can reference the secret to get the credentials into your application. So that it is a bit more integrated there. In Servala, we will be getting there. any other questions? Otherwise, we can discuss more in beers afterwards. Thank you.